Good afternoon, class. In today's video, what I'd like to do is to go over angular momentum. So in the introductory video, we already went over L equals I omega, which is the normal angular momentum equation. We also went over in the last video I, which is given by my star mr squared, which is, again, like I said in the last couple videos, don't worry about it. It's something that only I've invented. I added this one to it. But it's important to go over, and I showed you that list in the last video of certain geometric factors in the moments of inertia as that you would fill in for I. I mean for star, whatever that is, and you just fill it in. It's just plugging it in. It's a constant. It's fine. So let's talk about some of the consequences of that, because as you can see, angular momentum is directly proportional to moment of inertia. It is directly proportional to angular velocity. However, moment of inertia and angular velocity are inversely related to each other. What that means is that if the angular momentum, L, is constant, then I can change the star, the geometric factor, I can change the radius, I could change the mass, and either one of those, any one of those three things change, as long as the others don't change as well, because then, and even if they did, it doesn't really matter. If all of this stuff changes, this omega, as you can see from these results, it will always go down, as long as these start going up. So if I make this geometric factor go up a little bit, then my omega is going to go down by the same amount. If my r goes up, I'm going to slow down. If my mass goes up, I'm going to slow down, at least rotationally. So that's one of the results I'd like to put in there. I just wanted to make sure that that was, fairly clear, because if you see how all of this goes, then it should be a little bit more intuitive to figure out what's going on, especially when you watch people like ice skaters do some crazy spins that you wouldn't necessarily expect them to be able to pull off, given the fact that it's just them, their ice skates, and the ice, and nothing else. And yet they can spin at crazy speeds. So hopefully that gives you some idea of what they're doing to change, what factors they're changing in order to affect the rotational speed, omega. So I'd like to leave it with you at that. Thank you guys so much for watching. Good luck in your studies. I'll see you in the next video.